Okay, so this week's lesson is on 3.4, which is slope-intercept form of a linear equation. So we're going to start with what slope-intercept form is, and that is the equation y equals mx plus b, where m is your slope. So we learned that in 3.3 what the symbol for slope is. And then 0, comma b is the y-intercept. So the value for b is where the graph hits on the y-axis, as you can see on this graph. So b is where it crosses the y-axis, and then you may have some other point. But for slope-intercept form, you need to know the slope and you need to know the y-intercept. So we're going to start with some examples where we will identify the slope and y-intercept if they exist. So I'm going to grab my pen here. So the first equation we have is y equals 2/3 x plus 5. So slope-intercept form is y equals mx plus b. So our first equation is in that form. So the number that's in front of x when it's solved for y, that is your slope. So m is equal to 2/3. The value that's added or subtracted to something with x is the y-intercept. So this is our y-intercept. And we write it as 0, comma b, so that's going to be 0, comma 5. Now the equation on the right, we have 3x plus 2y equals 9. And in order to determine the slope and the y-intercept, you have to solve the equation for y. So this is not in slope-intercept form. So I'm going to start by rewriting our equation and then start solving. So when we solve, we want to move the x to the side that's not with the y. We basically want the x on the other side. So I'm going to subtract 3x from both sides. So this gives me 2y equals 9 minus 3x. Now we want to get rid of the 2 that's in front of the y. So we're going to do that by dividing everything by 2. And this means everything. So every term gets divided by 2. So that will leave me y equals 9/2 minus 3/2 x. So now we're in slope-intercept form. Even though the x is last, it's still slope-intercept form because we still have it solved for y. So now we need to identify what the slope and the y-intercept are. So our slope is always the number in front of x. So in this case, that is -3/2. So m is -3/2. That is our slope. The y-intercept is the number that's added on, which in this case is 9/2. So our y-intercept will be 0, 9/2. Okay, same thing, two different equations here. So again, we're looking for the slope and the y-intercept. So the first equation here is -4 plus x equals 1. So we don't have a y in this equation. And if there's no y present, this means it is a vertical line. So if you just have something with x, there's no y, and you have a vertical line. And vertical lines, as we learned prior, have a slope that is undefined. And they have no y-intercept, unless it's x equals 0, or then it has infinite many. But we don't have that. So we don't even need to solve or anything here. We don't have a y present, which means we have a vertical line. So we automatically know the slope is undefined and there is no y-intercept. So now let's take a look at the second equation. We have 1 minus y equals 9. So if we have y, we're going to solve for y. So I have 1 minus y equals 9, and I want y by itself. So I'm going to subtract 1 from both sides here. So that gives me a negative y. You need to remember to drop down that negative in front of the y. Negative y equals 8. Now we want a positive y, so I need to divide everything by -1 to get rid of that negative sign. And we get y equals -8. So notice we don't have an x or anything here. So you could think of this as -8 plus 0x because the x is missing. So if you think of it that way, then our slope here is 0 because we have no x at all. And our y-intercept is the -8. So that is 0, -8. So if you don't have x, you still have a slope and you have a y-intercept. But when you don't have a y, that's when you're in a special case. Okay, so now the next ones we are going to be graphing. So graph the line given the slope and the y-intercept. So when you have a slope and a y-intercept, graphing is actually quite nice. So you first start with your point. So I'm going to start with the left one. We have a point 0, -1. So I'm going to just put a little circle there. That is our y-intercept. Now our slope of 3, if you have a whole number, you can write that as a fraction as 3/1. And if you remember that slope is rise over run, the rise is 3, the run is 1. So we're going to go up 3/1. And this only works if you are counting by the same thing on the x and the y. So here we're counting by ones in both the x direction and the y direction, so we are allowed to do this. So from my point, I'm going to count up 3 and then move over 1. And you can keep doing that. Count up 3/1, up 3/1. And you can even do the reverse. I can go down 3, but then I need to go left 1. Down 3, left 1. And so you can see, if I connect these, that will give me my equation for a line. So one way to do this without having to count the graph is to notice that the rise is y, the run is x. So when you're given the point, you can add 3 to y, add 1 to x, and that gives us a new ordered pair, 1, 2. So if I add it, I have -1 plus 3, that gives me 2 for the y, 0 plus 1 is 1. So that would give me my next location. Now, the graph on the right, we have a point 0, 3. So I am going to plot 3 on the y-axis. That's our y-intercept. And then the slope is -1/4. So when you're thinking of the slope of -1/4, you can think of that. Usually we put the negative on top. So the rise, we're going to go down 1, and then the run, we're going to go over 4. And if you want to think about this in terms of ordered pairs, we're subtracting 1 from y, and then we're going to add 4 to x, and we're going to get another point 4, 2. So my graph, I'm going to go down 1 and then to the right 4. and that gives me another point. And then I can go down 1 to the right 4. And if you go in reverse, you're going to go up 1 to the left 4. Up 1, left 4. And then I'm going to attempt to connect these. Not the best. I missed my 8. But it's close enough. I missed my last point. We'll just do that. And you can see that that gives you your equation of a line. And you can see that just like I did the math, my next point was 4, 2. And you can see that on your graph. Now, when you have something that's not in slope-intercept form and you want to graph it, the best thing to do is to put it in slope-intercept form and then use the slope and the y-intercept to graph. So we have negative 6x plus y equals 8. So to put this in a slope-intercept form, I'm going to add 6x to both sides. So this gives me y equals 8 plus 6x. And it's good to identify each part. So the number in front of x is our slope. So our slope here, m, is equal to 6. So we're going to write that as a fraction, which is 6 over 1, which means we're going to be going up 6, and then we're going to go to the right by 1. Now we also have our y-intercept, which is 8. So that means I'm going to write it as our ordered pair. Our y-intercept is 0, 8. So it is actually not on my graph there that I put in there. It's right up there. So notice if I go to the right, if I rise 6 and run 1, I'm going to go off my graph. So when I'm going to plot this, I'm going to go in the reverse like we did on the other one. I'm going to go down 6 and left 1. We're going to reverse everything. So I'm going to go down 6, left 1. Down 6, left 1. And then that will allow you to graph, well, very bad straight line, but it allows you to get more ordered pairs so that you can graph that equation. So showing this, if we're going to do the reverse, it's basically with your y-intercept, instead of adding 6 and adding 1, you're going to subtract 6 and subtract 1 when you're reversing. It gives you another ordered pair, negative 1, 2. And then you can do that again, and then that will give you your negative 2, negative 4. So when you're reversing and you're going in the opposite direction, you just reverse the signs of whatever you have. If they're positive, they're now negative. If they were negative, then they would be positive. Okay, so now we're going to write x minus y equals 0 in slope-intercept form and graph the line, just like we did on the other one. So again, I want to solve this for y. And because it's set equal to 0, it's easy enough to just add y to both sides, which gives me x equals y. So I'm going to just rewrite this. Y equals 1x, and then we don't have a number added on, so I can put plus 0. So this is slope-intercept form. So our slope, m, is equal to 1. So we would write that as a fraction as 1 over 1. So we're going to go up 1 over 1. And then the y-intercept is at 0. So that's going to be 0, 0, which is the origin. So I'm going to be starting at the origin and then going up 1 over 1. And you can see this is really easy to graph because it's just pure diagonal here. And the more points I have, the easier it is for me to get a straight line. So then I just connect all of those. It's not perfect, but that's our graph. So our slope-intercept form, you can write it as y equals x. Or you could write it as y equals 1x plus 0. And then you connect all of the points after you've graphed it using the slope, and then that is your line. All right, determine if the number of equations represent parallel lines, perpendicular lines, or neither. So what you want to remember here is from when you learned about slopes, parallel lines have equal slopes. So the slope of the first one equals the slope of the second. Perpendicular lines have slopes that multiply to -1. So m1 times m2 gives you -1. And if neither of those are true, then they're neither parallel or perpendicular. So we want to start by identifying the slopes for each of these. So the first line on the left will be out 1. The second one on the right, the second equation will be 2. So these will help. I will be labeling them. And then the number that's in front of x is our slope. So m1, the first slope, is 4/3 because that's the number in front of x. And the number in front of x in the second line is -3/4. So m2 is equal to -3/4. Now we can see that these are not the same. These numbers are not the same. 4/3 and -3/4 are not the same, so they're not parallel. Because m1 does not equal m2. So the next thing is to test if they're perpendicular. So we're going to do that by multiplying the slopes together. So m1 times m2 is -1, and I'm going to replace them. So 4/3 times -3/4 equals -1. So -4 times -3 is -12. 3 times 4 is 12. And -12 divided by 12 is -1. So we do get something that's equal to -1. So because that was true, these equations are perpendicular. I'm going to just take a moment to turn off my notifications so I don't get any more sounds. Okay. Now we're going to do it again. This time these two lines are not in slope-intercept form. So the best way to find if they're parallel, perpendicular, and so forth is to actually put them in slope-intercept form. So I need to solve both of these equations for y. So I'm going to start by rewriting them. So that way it just looks a little easier when I start solving. So I'm going to start with the one on the left, 4x plus 5y equals 20. So if we're solving for y, we want to subtract 4x from both sides. That gives me 5y equals 20 minus 4x. Now I want to divide everything by 5 because I want just y, I don't want 5y. So I'm going to divide everything by 5. So this gives us y. Oops, I want to make sure that's in black. Y equals 20 divided by 5 is 4. And then we get minus 4/5 x. So now I'm going to do the same thing with the one on the right. We have 5x minus 4y equals 60. So I want to solve for y, which means I'm going to subtract 5x from both sides. This gives me -4y equals 60 minus 5x. Now I want to get rid of -4 because I want just y. So I'm going to divide everything by -4. And this will give me y equals 60 divided by -4 is -15. And then we get a positive 5/4 x. So now we need to take a look at the slopes. So the slopes are what's in front of the x. So the slope of the first equation is -4/5. The slope of the second is 5/4. If they're parallel, those slopes would be equal, but these are not equal. So we can rule out that they are parallel. Next is perpendicular. The shortcut for perpendicular is, are they reciprocals? And do they have opposite signs, one positive, one negative? It'd help if I spelled the opposite right. So reciprocals would be if, you can flip it if you ignore the sign. So 4/5 and 5/4. So those are reciprocals. And then we have one of them is positive, one of them is negative. So that means that they are opposite signs. So if both of those are true, that means that these are perpendicular lines. Okay, write an equation of the line given that the slope is 2/3 and the y-intercept is 0, -1. So we're going to start with our slope-intercept form, y equals mx plus b. So if they're giving us the y-intercept, that is equal to b. So we can just replace b with -1. And then the slope is m, so we can plug that in for m. So that will give us y equals 2/3 x minus 1. So that is the equation of a line given the slope of 2/3 and a y-intercept of -1. So you're just basically replacing the appropriate numbers or letters in the equation. Now, write an equation of the line given that the slope is -4 and the line passes through the point 4, -3. In this case, they're not giving us the y-intercept because the y-intercept has an x value of 0. So they're not giving us a y-intercept. So it's not going to be so easy to plug it in. But we're going to sort of start with the same steps. So we're going to start with our slope-intercept form, which is y equals mx plus b. And I can replace my slope m in the equation. So we know that it's y equals -4x plus b. In order to write our equation, we need to know what b is. That is what we are looking for in order to write our equation. In order to solve for b, we need to replace numbers for x and y in our equation, and that's where we're going to use that second point. So that second point for -3, we're going to plug those in for x and y. So the y value in the ordered pair is the second number, so that's -3. And then I have -4 times x, and the x is the first value, so that's going to be times 4. And then we have plus b. So now you see we have one variable and we can solve for b. So I'm going to start by multiplying -4 times 4. So I have -3 equals -16 plus b. Now I'm solving for b, so I want to add 16 to both sides. Make sure I'm in the right colors. So we have Negative 3 plus 16, that gives us 13 equals b. So now we know what b is, so we know the y-intercept. The y-intercept is 0, 13. So once we have that information, we can finish our equation. Slope-intercept form, y equals mx, so m is negative 4, plus b, which is 13. So that gives us our equation for the line going through those 2 points. Now this is my last example. Write an equation of the line given that the slope is 0 and the y-intercept is 6/7. So slope of 0, that is special. Slopes of zeros are horizontal lines. And they are always of the form y equals a number for the equation. So that means all we need to know is what the y value is, and they tell us the y value is 6/7. But let's use slope-intercept form to get the same answer. So slope-intercept form is y equals mx plus b. And so our slope is 0. So m is going to be 0. And then our y-intercept is b. So 6/7 is going to be b. So we're going to have y equals 0x plus 6/7. And then 0 times anything is 0, so that 0x disappears, and we get y equals 6/7. And that is the equation. You will, oops, I accidentally erased my box. You will get a horizontal line if you graph that. It will go straight across, slope is 0, and it's going to go through the y value of 6/7. So that is it. That is 3.4 in a nutshell. 3.5 is point slope form, which is an alternate way of writing equations of a line. And so you can use point slope form for your discussion, or you can use slope-intercept form. But hopefully this has given you enough information to kind of understand how to write your equations and how all that fits in. If you have any questions, let me know. Bye.